My name's Don. Welcome back to Project Urtle. In this episode we're going to raise the roof. Well, I'm going to use linear actuators to automatically raise a roof. The episode spans a number of weeks. It starts out prior to the canvas sock having been constructed and installed on the pop top, and finishes well after it has been installed. The camper is basically finished. I'm still waiting on my canvas man to make me the canvas sock for the pop top, and I've been just tidying up little odds and ends around the build for a few weeks now. One of the things that has become obvious to me is that I'm having difficulty raising and lowering the pop top roof. So I've been casting around for an alternative, and this is what I've come up with. It's still experimental, but in this episode we're going to work through this particular version of the experiment. What I've decided to try is to use an electric linear actuator. And so, as is my style, I went searching on eBay, and this is what I found. This is an offcut of the aluminium extrusion that forms the lower portion of the pop top, and this is the position where roughly the linear actuator would sit. And this is a section of the roof pop top, and that sits down there, and yes, the linear actuator fits inside, so that's first step ticked. The linear actuator comes with a motor control unit, and it also comes with a little remote control fob which does the same thing. What I need to know is whether this motor controller will drive two linear actuators in parallel, and that's what I'm about to try now. I have an old computer power supply here which I've had for quite a while, and I've wired it up so that it gives me a 12 volt DC power supply. Okay, now time for the smoke test. Alright, we have a little LED power light showing here, and if we try one of the buttons, we should make some noises, which we do. And if I try the other one, yeah, okay, I'll set the camera up so you can see this. Yep, that's working. So it's a momentary action push switch here, but there are some limit switches on the linear actuators themselves which stop the motors automatically when they reach their home position, and that also does it when they're fully extended. The next question is, do I have any room to mount this controller in my electrical cabinet? As you can see, the electrical cabinet is pretty full, but as is often the case in this build, the system comes together with just millimeters to spare, and I've noticed that I have a little spot here. I can put the control box in that little spot and wire it down into that little fuse. We interrupt this programming for some important information. It didn't work. Well, it did work, sort of. The intent was to have those linear actuators driving horizontally onto the bottom of the scissor lift, and in doing that it would push the scissor lift up into its lifted position, this kind of an action. Adrian and I made some bracketry. We mounted it up on both sides, and it worked. There was a fair bit of load happening. You could hear the motors loading up, but it worked for a few weeks, basically while I was here at home, lifting the roof up and down to work on it or put it away of the evening. And then one day one of the brackets bent and the actuators kept going and basically destroyed all the brackets. So I had to go back to square one. All the thinking processes and what I've showed you so far still apply, but now we're going to go in a completely different direction. Instead of horizontal, we're going to lift dead vertical. So we'll take you back to programming as planned. Here I've mocked up how the system will work. This is a piece of the roof extrusion, and this is a piece of the wall top extrusion. We've drilled a hole through here for the ram to run up through, and it will push here on this roof extrusion to lift the roof. Now we'll have to make a bracket here that attaches the ram to the roof so that we can use the ram to pull the roof back down again as well. The ram itself will be attached to the wall, and the wall itself runs down through that area down there with the ram attached to the back of it. In this section, through here, through the hole, to keep it weatherproof, I'm going to use a piece of this Delrin engineering plastic, which will turn up, bore a hole through the centre where the shaft of the ram can run, and we'll insert a couple of O-rings in there to keep the weather out. So now I was off over to Adrian's shed where he milled up the brackets to hold the seals and welded the top brackets for me, and I really got to say thank you over and over again, because he's enabled so many of the more technical parts of this build, and without him I really couldn't have done it. Okay, well, the results of Adrian's fine work was to produce some parts for me. To start with, this is the extrusion which sits on top of the wall and takes the canvas for the pop top. And I've just set this up as a test piece, but actually on the camper I've bored this hole through. It comes down inside the wall. This is the linear actuator that I'm using. It's 700 millimeters long with a stroke. Well, actually it's a 700 millimeter stroke, and that will come up through that hole. Then that hole, of course, is open to the inside of the camper and would let rainwater in when the roof is up. And so we've made machined up a piece of Delrin plastic and inset an O-ring in there, which runs tightly down that shaft. Now, in order to hold that down, we've milled a groove in there, and we've made these clamp blocks which slide in from each side like that, and then have a couple of screw holes here for screwing that down. That anchors it physically down so it can't slide up when the ram slides up and down, and clamps this down so that I'll put some sealant underneath there to stop that leaking. Okay, that's that part of the equation. This runs a little freer if I put a little bit of Vaseline on it. Underneath here, this ram is poking up too high. This is the pop top extrusion, and as you can see, it wouldn't let the whole roof come down and seal on that surface. So in order to overcome that, Adrian machined me up this spacer block, which sits in there, so that that sits down there, and there is now plenty of room for that ram inside of that extrusion. Now on top of the ram, we've made this bracket which bolts onto it there, and that bracket will spread the load, the point load of that ram along this extrusion, and basically push there. I'll have a couple of bolt holes drilled through the top into the bracket, and the bracket will be drilled and tapped to take those bolts. And again, sealant placed there to stop it from leaking. At the bottom end of the ram is a mounting point, and Adrian's welded me up this bracket, which when fitted there and pinned through will allow me to screw and glue that to the inside wall of the camper. So that should be alright. Today's job is to fit all the parts, wire it up and see if it works. Okay, we've got a long shot here through the through boot from the driver's side. I'm on the passenger side, and this is where that linear actuator is going to be mounted, tucked in alongside of the door jamb here. I've got the spacer that we talked about earlier, and that is just pushed up through the floor of the bed area over on the far edge, and is protruding out of the top of the wall extrusion. And this is the view from the top. You can see the ram poking out through the top of the wall extrusion and the seal in place. Okay, here we are, first thing next morning. All the glue behind all the brackets is set. So now is the smoke test. Wish me luck. At this point I realised that the remote control fob has a very definite limit, and unless I have my hand in relatively far underneath the overhang, I'm too far away from the control unit to operate successfully. But that's not really an issue. I plan to open and close it predominantly from the other side. Having done a quick walk around to make sure everything still looked normal, I had to try it down. It's not fast, but then hey, I'm retired. I've got time to wait for it.